When the wheel spins freely in the air, a point on the rim, like point B, moves in a perfect circle relative to the ground. The axis of the wheel doesn't move at all, it stays still. That means the wheel isn't rolling. It's just rotating around a fixed axis. Imagine watching motion all around you. Planes looping in the sky, bicycles rolling on the road, pulleys lifting heavy loads, and helicopter blades slicing through the air. All of these motions look different, but they follow very clear patterns and rules. In today's video, we're going to break these motions down in the simplest, most visual way possible so you can understand not just what happens, but why it happens. Let's start with different types of trajectories. Picture an aerobatic plane flying high in the sky. When it moves straight from point A to point B, its path is a rectilinear trajectory, a simple straight line. But when it curves from B to C, the plane follows a circular arc, bending its path just like a part of a circle. And once it exits the curve from C to D, it goes back to a straight line motion. So the whole flight shows how motion changes depending on forces and direction. Straight, then curved, then straight again. Now let's move to a pulley lifting a heavy load. You've probably seen this in cranes, elevators, or even simple physics labs. When the load is lifted upward, the load itself moves in a straight vertical line. That's rectilinear translation. The pulley, however, rotates around its fixed axis, so its motion is rotational, not translational. And the rope segment between 2 points doesn't rotate at all. It simply moves straight upward. This simple system gives us 3 different types of motion at the same time: straight line motion for the load, rotational motion for the pulley, and rectilinear translation for the rope. Next, let's look at a cyclist who turns their bicycle upside down. When the wheel spins freely in the air, a point on the rim, like point B, moves in a perfect circle relative to the ground. The axis of the wheel doesn't move at all, it stays still. That means the wheel isn't rolling. It's just rotating around a fixed axis. But once the cyclist flips the bike back and rides on a straight horizontal road, everything changes. A point in the middle of the handlebar stays at rest relative to the cyclist, but moves forward relative to the road in a straight line. And the wheel now combines 2 motions: rotation around its axis and translation as the bike moves forward. That combination is called rolling motion. The wheel spins, the axis moves forward, and together they create smooth, continuous motion along the road. Finally, let's study a helicopter lifting off the ground. A point at the tip of a rotor blade moves in a circle relative to the blade. That part is easy. It's also circular relative to the passenger cabin because the cabin rises but doesn't rotate with the blades. The helicopter's body, point O, moves straight upward with a vertical rectilinear motion. But here's the most interesting part. What is the path of that blade tip relative to the ground? Since the helicopter is rising while the blade is spinning, the point traces a helical path, a shape like a stretched out spring. It's the combination of vertical translation and circular rotation happening simultaneously. All of these examples show us one key idea. Motion depends on the reference point you choose. The same object can have a circular trajectory from one reference frame, a straight trajectory from another, and a helical trajectory when motions are combined. Understanding this helps you analyze real-world systems, break down complicated motions, and solve physics problems with confidence. If you found this helpful and want more clear physics explanations, don't forget to like the video and subscribe to the channel so you don't miss the next lessons.